today we're going to do these two proofs that you see here using the rules set out, right? We have the rules of Modus Ponens, Modus Tollens. We have the rules of disjunctive syllogism and hypothetical syllogism. So we're going to go through these and understand exactly how to prove what we're setting out to prove. Looking at problem 1, we're trying to prove that if U, then P. That's what that U, the slash U horseshoe P means. If U, then P. How would we go about showing that? Well, we look back at our premises. We have 3 premises here. And the second one you'll notice says that either C or if U, then P. Now that's useful. And it tells us by the rule of disjunctive syllogism, which we know, that if this is the rule that basically says, if I have a coin in one hand and it's not in this hand, then it has to be in this hand, right? So if not U, then if U, then P. So that means that if we could, if not C, then if U, then P. So if we could just show that not C, we'd be able to solve this thing, right? Well, oh, wait a minute. Premise number 1 says that if J or R, then not C. So it would be really useful if we could show that J or R. Oh, wait a minute, though. That's what premise 3 actually says, literally is J or R. So if we want to, okay, am I able to, number 4, okay. Now we can say it for number 4. So what order do we do this in? First of all, we look at number 3 and number 1 and we say, very simple. This is a Modus Ponens solution here, right? We simply, MP is our rule that allows us to look at 1 and 3. If J or R, then not C. J or R, therefore not C. Okay, so now by Modus Ponens, we've discovered the answer to that. Now what's our next step? Well, for step 5, let's look. Now that we have not C, we can look back at number 2. And remember the thing about the 2 hands that I said, right? This is called disjunctive syllogism. By the rule of disjunctive syllogism, because we know that C is not the case, we are able to say that if U, then P, the other alternative in our disjunction, right, in our or statement, must be the case. If U, let me just grab a horseshoe here and copy it. If U, then P. And that is by the rule of disjunctive syllogism based on number 2 and number 4. And you'll notice that we've just gotten what we had set out to prove, if U, then P. So that is our QED, quadrat demonstrandum. Now let's look at problem 2. This one is a little bit more sophisticated, but it's still quite doable. You've got a very long, complicated premise at the beginning there, and you might feel like, oh, gee, that is intimidating, right? But don't be intimidated by it. This is actually very simple if we break it down to its elements. Now we start off, let's look at what we're trying to prove here. We're trying to prove that not N, okay? Now, do you see not N anywhere in here? Well, yeah, it's in that big jumbly mess of stuff in line 1. That's fine, but let's look further down, okay? Line 2, we see a conditional statement. If E or not J, then B. But then we look down at number 4 and we see E or not J. Hey, that's easy. That is a simple Modus Ponens situation where we now know that B has to be the case. How do we know that? Because of numbers 2 and 4 and the rule of Modus Ponens, okay? So we deduce from the fact that E or not J, that B is the case. Now that we know that B is the case, what are we going to do? Well, I would suggest look at number 3. Premise 3 says, if not U, then not B. Well, we have a rule called Modus Tollens, which is sort of the cousin, you could say, of Modus Ponens. Modus Tollens says, if A, then B, not B, therefore not A. So we can't quite do that yet. The first thing we need to do is use the rule of double negative to show that not B, right? So this is a simple rule that says that not B is the same as B, called double negative. So that gives us number 6, double negative applied to number 5. But now we can take number 6, okay, and we can do modus tollens, looking at number 6 and number 3, right? So that shows us that not U based on Modus Tollens 3.6. Okay. Now, now that we know that not U, by the same logic, using double negative, right? We can, or by the reverse logic, we can say that not U is the same as U. That is simply the rule of double negative applied to number 7. Okay. Now we know that U and we know that B. Now, when we look up at that big jumble of stuff in the first premise, it's not so hard to read anymore. Now it's going to be a lot simpler. For example, now that we know that U is the case, we can conclude that that first U, if U then blah, 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 well, now we can say that blah, blah, blah is the case. So let's just copy and paste this whole thing inside the brackets, right? Because that first U is the case, it follows that this whole thing is the case. And that is based on Modus Ponens, number 1 and number 8. Okay, now we can go further than that, though, because we know that, U, we know that U is the case, and we know that if U, then if B, then not N. Well, since U is the case, then if B, then not N has to be the case. Again, by the rule of Modus Ponens, this time numbers 8 and 9. Okay, and finally, we are able to conclude from that, if B then N, we'll look back at number 5. It was our step 5 that showed that B. So if B then not N, B, therefore, by again Modus Ponens, we can conclude that not N. Okay, Modus Ponens 5.10. And not N, of course, was what we had set out to prove in the first place. So that is how to solve each of those, applying at each step one of the rules that we learned about natural deductive proofs. Thanks very much.